Actually, in this video, we'll be finding out the acceleration of an object rolling down an inclined plane. We already know that. Suppose if you have a mass m and if you leave that mass under gravity, we know that the acceleration downwards is equal to g, acceleration due to gravity. In laws of motion, we had already studied that. Suppose you have an inclined plane like this, very similar like this, and the same way it is theta. If you have a block of mass m, it will slide downwards with an acceleration a is equal to, if this angle is theta, then this acceleration a equal to g sine theta. That's what we have studied. Now here this is a case of sliding. Okay, this object is sliding downwards on a smooth inclined plane. This plane is smooth, whereas this has a friction, because we are going to consider a round object, and this round object will roll down. So when it is rolling down, its center of mass will move along the inclined plane, and at the same time this actually rolls, this actually rotates. It rotates as well as it moves down. So what will be that? So instead of taking a big object, let me take a very small one, and let us say it is here, and this is the object. It's a very small object and its mass is m. So we are going to find out what will be the acceleration downwards. You know that because it is going to roll, the center of mass, the moment of inertia matters. So here the acceleration, in both the cases the gravity is there, but because it is rotating, whenever there is a rotation, whenever there is a translatory motion, the force required depends on the mass. Whenever there is a rotatory motion, so the force required depends on the moment of inertia. So here the contribution of moment of inertia will be there. So that's what we are going to find out now. So if its mass is m, we know that downward force will be mg. So we know that this is mg. But if this plane is smooth, what this will try to do? This will try to slide downwards. So it tries to move downwards. So if an object is moving downwards, we know that the property of friction is to opposite. So the attempt of the object will be to move downwards, so the friction will act upwards. So the friction will act upwards. So this is the friction. Frictional force will act in the downward direction. If this is mg, so we had so many times learned that if this is mg, this can be resolved into two components. One is along this, which is mg sine theta, and the one is along this perpendicular to that, that is mg cos theta. So let us write that this is mg sine theta. Now you see one force is acting along the downward direction, which is mg sine theta. The other force, the frictional force, will act in the opposite direction, which is F. But we know that frictional force F is equal to mu times normal reaction. This is mg sine theta, we know. If this is theta, this is going to be theta, this is mg sine theta, this is mg cos theta. We know that normal reaction is perpendicular to the surfaces in contact. So the normal reaction will act in this direction. So this normal reaction is balanced by mg cos theta, because the object is rolling downwards. It does not exhibit, that is what we assume here, it does not exhibit any motion in this direction. It happens in this direction. So the normal reaction has to be balancing mg cos theta. So based on this, we know normal reaction n is equal to mg cos theta, and hence the frictional force F is equal to mu times normal reaction, so mu mg cos theta. This is what it is. So this one we had discussed in friction, so we know that. Now let us take two things of equilibria conditions. One is, there are two things happening here. One is translatory motion, but at the same time this is actually rolling. Because it is rolling, rotatory motion is also happening. Then there are two kinds of things are acting. So what causes translatory motion is force. So force causes translatory motion, and torque causes rotatory motion, and force is mass into acceleration. Force is mass into acceleration. Torque is, there are two things. For force, the mass is the position, the inertia, and here it is moment of inertia I. The acceleration is a, translational acceleration or linear acceleration. Here the angular acceleration alpha. How a and alpha is related? If it is a pure rolling, moreover here the assumption is also that it is rolling, so there is no slipping, there is no kind of sliding, it is actually rolling, it exhibits pure rolling motion. So in such case, when there exists a pure rolling, then alpha is actually equal to a by r. So we can say that a is equal to r alpha, where r is the perpendicular distance here. If this spheres a, or this cannot be a sphere also, it could be a sphere or a ring or a disc or anything, the radius of that is r. So in such case, this is r alpha. So the linear acceleration a is equal to r into angular acceleration alpha. So these are things that we need to know now. So one is force causes translatory motion. So there is, and the force is unbalanced here. So mg sin theta is acting downwards, whereas f is acting upwards, but still the object is going downwards. So as it is rolling, it is going downwards. So mg sin theta must be greater than f. In such case, one equation we will be writing for f, the other equation we will be writing for torque. But we know that torque is also equal to force into perpendicular distance. One of the force into perpendicular distance, the force causing into perpendicular distance. Let us write first force. See, if you look at the free body diagram means consider only this. Force to the downward is mg sin theta, force acting upward is friction. So we know that because it is going downwards, mg sin theta is greater than friction. So mg sin theta minus friction is the net force. We know that net force is equal to mass into acceleration. Mass of the object we have already assumed it to be m, that is why it is mg. So it is m into the acceleration downwards. The acceleration downwards along the inclined plane, we are assuming it to be a. So this is equal to ma. So mg sin theta minus f is equal to ma. Then the other part, so there is also rotation. It rotates about the center of mass. So this is the mass point, the center of this object. About this object it is rotating. And we know that the torque is force into perpendicular distance. So I'm trying to write this one clearly down here. And see here what happens. The friction that acts in the opposite direction is trying to rotate the ball or the round object in this direction. But there is also another force acting, which is mg sin theta. This mg sin theta, because it is acting through the center of mass, the torque is equal to 0, because torque is force into perpendicular distance from the axis of rotation. Because mg sin theta is acting through the point, the axis of rotation, the distance, the perpendicular distance becomes 0 for this mg sin theta. So this mg sin theta will not produce any torque. Only this frictional force, this one we are talking about, can produce torque. So in such case, force into from the axis of rotation, because whenever this object rolls, about the center only it rolls, about the center O only it rolls. So from that point, the distance, the perpendicular distance is equal to radius of the round object. So torque is equal to I into alpha. Here also we are supposed to write the net torque, because it does not produce torque, only this produces torque. So it is force F into torque, torque means force into perpendicular distance, which is R, equal to I into alpha. Alpha is equal to, you know what, A by A, R. So this A by R. In such case, this is for the first equation we have got, and this is the second equation we have got. So F is equal to I A by R square. And one thing you should know here is that for any moment of inertia, remember that moment of inertia of any object, suppose if you take a sphere or a disk, the moment of inertia of a disk is mr square by 2. This, apart from m, whatever remaining is there, that we call k square. That is, the where k is called the radius of gyration. So moment of inertia of any object can be written as mass of the object into square of the radius of gyration. Because here we have taken the mass as small m, this moment of inertia I can be written as, further can be written as, F can be written as I is mass into radius of gyration square into A by R square. Let's call this equation 3 and substitute equation 3 in the first equation over here. You know that mg sine theta minus m k square by r square into a equal to ma. So now mg sine theta is equal to ma plus ma into k square by r square. Take ma out, so we will be getting 1 plus k square by r square, which is mg sine theta. M and m will be cancelled, so a will be g sine theta by 1 plus k square by r square. So the moment of inertia the acceleration of an object down an inclined plane will be g sine theta by 1 plus k square by r square. There is also another way of coming at it, which I will tell you. There is a different way of deriving this equation. What is the meaning of this equation? Let us try to understand that meaning of this equation. Suppose you have got an inclined plane and you have got a disk, and the disk of mass m, then what is the, and this angle is theta. What is the acceleration of this downwards? What is a equal to g sine theta by 1 plus k square by r square. If this theta is 30 degree and this is a disk of radius r, moment of inertia of a disk can be written as m r square by 2. Here this is, any moment of inertia is m k square, where k square here is r square by 2. Then acceleration of a disk down an inclined plane will be g sine 30 degree, because we have assumed that this angle is 30 degree, 1 plus k square here is r square by 2. So r square by 2 by r square. Essentially these two r squares will be cancelled. So we will be getting something like g into sine 30 degree is 1 by 2, and this is 1 r square by 2 is there, so it is 1 by 2. 1 plus 1 by 2 is 3 by 2. These two will be cancelled. So the acceleration of a disk down an inclined plane of angle of inclination 30 degree will be equal to g by 3. That is how we will be using this relation. In the next video, we will be watching the velocity. Suppose after sliding down an inclined plane, what velocity it will achieve, and then the time of sliding.